Hi class. Today we're going to cover elasticity. This is the probably most important topic that we'll cover between these two chapters, chapter 19 and chapter 20, that we're working on for week 3 in class. So first I'm going to talk a little bit about the basics of elasticity, what the concept means, and then we'll do an example problem together. So elasticity refers to the responsiveness of consumer demand as the price changes. So we know that demand is always downward sloping for normal goods. So if the price goes up, people will consume less. If the price goes down, people will consume more. That's the law of demand. Elasticity aims to measure by how much people will either increase their consumption or decrease their consumption in response to that price change. Depending on how strong or weak the response is, you can say whether the demand is inelastic or elastic. So I'm just going to show you a few examples without numbers, just kind of on the graph, so you can get, sorry, it's not straight. So you can get an idea of what it looks like graphically, and then we'll do an example as well. Okay. So elasticity is somewhat related to slope, as we'll see, although the formula for calculating elasticity is kind of the inverse of what you would do for slope. Slope, as you probably remember from algebra way back when, is rise over run. With elasticity, we do it the other way around. So we'll squeeze in one last graph there. This is just our normal graph of price on this side and then quantity for all these down here. I'm just going to put P's here. So I'll do a few different colors so you can see. So the first example, we're going to imagine this is something like the example I gave you in our announcement that this is electricity. So demand for electricity is going to be pretty inelastic. So it means two things. As you can see from the slope, it's very steep. If the price, let's say we start here, that's where the price is. So we have our price where we're starting, we have our quantity where we're starting. If the price were to go down to P2, you'll notice that people don't consume that much more. The quantity only increased by a small amount, graphically, as you can see, relative to the price. So electricity is one of those things where you have how much you need, and that's pretty much how much you use. You might use a little bit more, be a little bit more frivolous with electricity if you know that it's inexpensive or less expensive than it was before. But you're basically going to stay right around the same quantity regardless of the price. The same is true for a price increase. If the price were to increase to P3, you might cut back somewhat, but you're not going to cut back as much. You can see that going from this amount, the price change was larger relatively than the quantity change. So this shows a demand that would be inelastic. You're not going to respond as a consumer. You're not going to change your consumption that much relative to the price change. So here we have an example. I'll do it in a different color. That's going to be right in the middle. I'll try to draw it as best I can. So this is inelastic. So this is going to be our example of unit elastic. Now this is when consumers change the amount that they buy exactly proportionally to the price change. So an example of this might be, let's say that you have a specific budget for going out to the movies in a year. If the price of the movie goes up 10%, you need to consume 10% less, so you can keep that you're spending the same. So you won't spend any more or any less because of the price change. So if the price starts here and goes up to P2, this distance will be exactly the same. I mean, this is just my graph, but should be exactly the same as the quantity distance. Now again, this is assuming that these are relatively the same amount, but your spending would be the same in this case. So the revenue that the company brings in would be the same as well. If they were to increase their price, consumers respond exactly proportionally, they're still making the exact same amount of money. I'm still spending the same amount of money, they're still making the same amount of money. In this instance, the price increase, since people didn't cut back that much relative to the price change, they actually increased their revenue, and I increased my spending. Or all consumers increase their spending. This one is exactly even. That's why they call it unit elastic. And this is equal to 1. So it's that very specific spot. And anything right around 1 is going to have, it's going to be very close to unit elastic. But if it's anything lower than 1, when we do the calculation, which we'll do in a minute, this is less than 1. It's inelastic. And last is our elastic demand. So elastic demand, it'll be a flatter curve. So a price change causes a dramatic or relatively dramatic change in consumption. So you can see, I'll get out of your way. Went from P1 to P2, you went down by that much, and you can see that the quantity was a much bigger shift. Now, an example of that might be something, let's say, something you don't need very much of, might have an elastic demand, like maybe shoes, new shoes. I might buy a lot of new shoes if they're on sale. Hey, what the heck, why not? I might be very responsive to a sale or a price change, just because something extra, like maybe handbags or something like that. Just things that are necessities, things that you don't need. Tend to be like something that has a lot of substitutes tends to be really elastic. So if one store has a sale on shoes, I can get shoes anywhere, but since the store is having a sale, I might stock up on their shoes while they're cheaper. And vice versa, if the price were to go up, you'll see that people cut back quite a bit. So the shoe example would work the same. If one brand of shoes was very much increased in price, people could easily just stop buying those shoes and buy shoes elsewhere from a different brand. So elastic demand, when we calculate it, it's not really the slope, but the calculation will always be greater than 1. So those are the definitions. Inelastic demand, when you calculate it, is less than 1, the ratio. Unit elastic is exactly 1, and elastic is greater than 1. So now we're going to do a problem from your textbook. And I'm also going to put this in the discussion board for you all in case you have questions. I'll write it all out like I'm doing here, but that way you can see it statically instead of on the video. So this is number 19-4 from your textbook. And I'll show you how to do the calculation the right way. It's a little different than you might expect, and hopefully you've read through it in the chapter already. So 19.4 in your textbook, it's on page 432. It says, in a local market, the monthly price of internet access service decreases from $20 to $10. So this is internet. So that's the price. And the total quantity of monthly accounts across all internet access providers increases from 100,000 to 200,000 accounts. So we see the law of demand. The price went down, accounts went up. Now we just want to know by how much. What was the relative responsiveness? What was the elasticity of this of demand in response to this price change? So to do that, we need to get our formula. So I'm just going to call it PED, price elasticity of demand. So price elasticity of demand. All right, and the way we calculate this, or the basic way, it's going to be an absolute value. Usually the number is always going to be negative because it's inverse. So if one goes up, the other one goes down. If the price goes down, the accounts in this case, or the quantity goes up. So it will always be negative. So generally in economics, they just report it all as positive. Don't ask why. Every once in a while in your textbook or in the quiz, they might specifically tell you to report it as negative. So just read carefully on any quizzes or tests about that. So here is the definition. It's a percent change in quantity, just put in Q, over the percent change in price. That's an absolute value. Now to get the percent change for each one, we use the midpoint method so that a large swing in quantity or price doesn't throw off the whole thing. You can do some examples of it to prove that it really potentially could mess it up. These numbers are so big, 100,000 is so much bigger than 10. Those are times when it might happen. You can do some sample problems, or you can just take my word for it. But this is the midpoint method, that's how it's referred to, and that's what I'm going to show you to do now. So to get the percent change in each one, I'm going to put it over here. So the triangle is just change, delta. Percent change is the new value, take away the original value, over, now this is how you get the midpoint, the halfway point. You do the new plus the original. I'll get out of your way so you can see. And then you divide that by 2. So that's how you get your midpoint. So this is the midpoint method. So now we have our numbers. Excuse me. So we start with the percent change. So we're going to have 200,000. Okay, no. Yeah, the new, sorry. 200,000, take away 100,000, all over, now again we're doing the midpoint, so we're going to add them up, plus 100,000 divided by 2, all that, there's our absolute value, all that, same thing on the bottom, but with the prices, so the new is 10, so 10 minus 20, all over 10 plus 20 divided by 2. Now when you do this math out, make sure you're just careful with the steps, just basic algebra, but you just want to be mindful. You make a mistake, you won't be able to know if you got it right or wrong if you just make a simple algebraic mistake. So be careful with that. You get 0.667 over negative 0.667. And that, the absolute value, just equals 1. So make sure you can see that. So, with a value of 1, we know that this means that we have unit elasticity. So the percent change in price led to an exactly the same percent change in quantity. If the quantity change had been more, since it's the numerator, this number would have been greater than 1, and that would have been elastic demand. So the quantity would have changed, the percent change in quantity would have been more than the percent change in price. People are more responsive, they are more elastic in their demand, elastic demand. If the percent change in quantity had been less than the percent change in the price, in absolute value terms, then we would have seen something less than 1, which would indicate inelastic demand. So this is the basic formula. I'm going to put this whole problem up on the general discussion board. That way you can respond to it there if you have questions, and I'm happy to answer any of those. This formula is of course in your textbook. This is just a quick demonstration so you can see what it looks like as you practice them. So please let me know if you have any questions, and make sure you practice this a bit because this is definitely going to be covered on the midterm coming up next week.